Hello everyone, my name is Amrit Mang with roll number 20NS0422 of Namchi Government College studying in third semester, and I am here to present my presentation on the verification of truth table of logic gates and their simple combination using integrated circuit. In this topic, we are going to cover the introduction and working of logic gate, the types of logic gates and the verification of each of the types, and the combinational logic circuit, and the conclusion. First, let us introduce what do you mean by logic gate. A gate is a digital circuit that follows certain logical relationship between the input and output voltage. It is an idealized model of computation or physical electronic device implementing a Boolean function, a logical operation performed on one or more binary inputs that produces a single binary output. Digital logic gates are simply a string of transistors working together to solve basic Boolean functions. A logic gate is considered as a device that has the ability to produce one output label with the combinations of input label. Logic 1 represents high and logic 0 represents low. Here, various combinations of binary mathematical functions are applied to show the true state of the digital system. The working of the logic gate. The reason for which the computers are capable of performing complex operations is due to the interconnection of these logic gates. Logic gates are implemented by the using transistor, diodes, relays, optics, and molecules, or even by several mechanical elements. Due to this reason, the logic gates can also be considered electronic circuit. The logic gates can be built up in a wide variety of forms such as large-scale integrated circuit (LSI), very large-scale integrated circuit (VLSI), and also in small-scale integrated circuit (SSI). Here, the inputs and outputs of all the gates of integrated devices can be accessed, and also the external connection are made available to them just like discrete logic gates. Two logic labels. Inputs and outputs of logic gates are in two levels termed as high and low, true or false, on and off, or simply 1 and 0. A table that lists out all the combinations of input variables and the corresponding output variables is termed as truth table. A truth table defines the functions of a logic gate by providing a concise list that shows all the input states in tabular form of each possible combinations of input variable that the gate could encounter. It explains how the logic gate or circuit output responds to various combinations of logic labels at the inputs. The voltage labels are represented as logic 1 and logic 0. Label logic is of two types, such as positive logic or negative logic. Types of logic gates. There are mainly 7 types of logic gates that are used in expressions. By combining them in different ways, we will be able to implement all types of digital components. Let's dig deep into each of the basic logic gates and their operations. The types of logic gates are: number 1, AND gate; number 2, OR gate; number 3, NOT gate; number 4, NAND gate; number 5, NOR gate; number 6, exclusive OR gate or XOR gate; number 7, exclusive NOR gate or XNOR gate. Number 1, AND gate. An AND gate has two or more important inputs and only one output, which is equal to the product of all inputs. The AND gate is so named because if 0 is called false and 1 is called true, the gate acts in the same way as the logical AND operator. The following insulator and table shows the circuit symbol and logic combinations for an AND gate. In the symbol, the input terminals are at left and the output terminals is at right. The output is true when both inputs are true, otherwise the output is false. In other words, the output is 1 only when both inputs and 2 are 1. From the table, we can write as if one of the input is high, then the output is also high. When both the inputs are low, the output is also low. AND gate can be represented as the IC 7408. Number 2, OR gate. OR gate has two or more inputs and only one output. the output is equal to the sum of all inputs. The OR gate gets its name from the fact that it behaves after the fashion of the logical inclusive OR. The output is true if either or both of the inputs are true. If both inputs are false, then the output is false. In other words, for the output to be 1, at least input 1 or 2 must be 1. And from the figure and the truth table, we can write as if one of the input is high, then the output is also high. When both the inputs are low, the output is also low. OR gates are also available in terms of IC, and it is represented as IC 7432. Number 3, NOT gate. It is also known as the inverter gate. It has only single input and single output. In this gate, the output is the complement of the input logic. A logical inverter or NOT gate, to differentiate it from other type of electronic inverter devices, has only one input. It reverses the logic state. If the input is 1, then the output is 0. If the input is 0, then the output is 1. NOT gates are available in terms of linear integrated circuit, and it is represented by IC 7404. Universal gates. It is a gate which can be used to implement any other gates without using other types of gates. A universal gate is a gate which can be implement any boolean functions without need to use any other gate type. There are two types of universal gates, the NAND gate and NOR gate. In practice, this is advantageous since NAND and NOR gates are economical and easier to fabricate and are the basic gates used in all IC digital logic families. Number 1, NOR gate. NOR is a combination of NOT and OR gate. It has two or more inputs but only one output. The output is the complement of the sum of the inputs. And from the truth table, we can write that if the input is high, then the output will be low. But if the both of the inputs are low, then the output will be high. Number 2, NAND gate. NAND gate is the combination of NOT and AND gate. And in this gate, it has two or more input but only one output. The output is the complement of the product of input. And from the truth table, we can write that if any of the inputs is low, then the output is high, and if all the inputs is high, then only the output is low. Combinational logic circuit. Unlike sequential logic circuits, whose outputs are dependent on both their present inputs and their previous outputs, instead giving them some form of memory, the outputs of combinational logic circuits are only determined by the logical function of their current input state, logic over logic 1, at any given instant time. In automata theory, combinational logic, also referred to as time-independent logic or combinatorial logic, is a type of digital logic which is implemented by Boolean circuits where the output is a pure function of the present input only. In combinational logic circuit, the output is dependent at all times on the combination of its input. Thus, a combinational circuit is memoryless. So, if one of its input condition changes state from 0 to 1 or 1 to 0, so too will be the resulting output as by default combination logic circuit. The logic circuits are made up of from basic logic, NAND, NOR or NOT gates that are combined together to produce more complicated switching circuits. Combinational logic circuits can be very simple or very complicated, and any combinational circuits can be implemented with only NAND and NOR gates, as they are classed as universal gates. The three main ways to specifying the functions of combinational logic circuits are: number 1, Boolean algebra; number 2, truth table; and number 3, the figure. Number 1, Boolean algebra. This forms the algebraic expression showing the operations of the logic circuit for each input variable, either true or false, that result in logic 1 output. Number 2, truth table. A truth table defines the functions of a logic gate by providing a concise list that shows all the output states in tabular form of each possible combinations of input variable that the gate could encounter. And lastly, logic diagram. This is a graphical representation of a logic circuit that shows the wiring and connections of each individual logic gate, represented by a specific graphical symbol that implements the logic circuit. All three of these logic circuit representations are shown below in the logic diagram. The Boolean expression of this diagram is Q equals to A dot B dash into A plus B dash dot C. And here is the typical truth table of the combinational circuit. And from this, we can conclude that the combinational logic circuits consist of inputs, two or more basic logic gates, and outputs. The logic gates are combined in such a way that the output state depends entirely on the input states. Combinational logic circuits have no memory, timing, or feedback loops. Their operations is instantaneous. A combinational logic circuits perform an operation assigned logically by a Boolean expression or truth table. Examples of common combinational logic circuit include half adders, full adders, half subtractors, full subtractors, multiplexers, demultiplexers, encoders, and decoders.